Okay.
Should I share my screen?
All yours, my friend. Go for it.
Um, I guess I would do that because it will be easier to guide through the whole process. So yeah, I just confirmed this morning that the last piece of the network policy MVC was pushed to production, and I checked that everything is working. So I think it will be a good time to show what we have in our demo projects because they cover all the parts of the Cilium deployments and network policy deployments. So it's a bit of a tricky thing to do um, demo because there are several pieces involved in the network policy deployment. As you may have read, policies themselves are already supported by the Kubernetes, but they have a hard prerequisite on container network provider with support for network policies. And we selected Asylum as such provider for this MVC. So the first step deploying network policies will be to set up a cluster with Asylum. We do that through the new thing called cluster management application. And the way it works is you create a cluster. For example, in my demo project, if I will go under the Kubernetes settings, I already have a network policy cluster created for the GitLab. And one important thing to do is you have to assign a cluster management project to this cluster. You do this by selecting another GitLab project in this dropdown, pressing save. In this particular instance, I have already assigned a network policy cluster management repository to be a management project for this cluster. So if I will switch to the management repository, this one, the structure is pretty simple. It relies on CI runner to deploy management applications to the cluster. You don't have to create a cluster in this repository. Cluster automatically will be derived from the settings we just assigned. Setup process is quite simple. GitLab ships a template that you can use in your CI configuration. So it's essentially 2 lines that you have to assign in your CI config. And by doing that, you will be able to enable certain applications in your cluster. For this particular repository, we have enabled an Nginx ingress to be deployed to this cluster and Cilium to be deployed to this cluster. So I have already run the pipeline for that. So if you will go into the log, for example, one of the older ones, you will notice that there are a lot of lines that will involve Helm. It's essentially will show you which Kubernetes resources will be deployed by the Helm, and you can see everything in the output in all the details that you need, and you can control the deployment process for the CI pipelines. In this particular instance, we can see that both Nginx and Cilium were installed successfully into this cluster. So yeah, as I mentioned, this is the first prerequisite to running to deploy a network policies into the cluster. So if we will go back into the actual demo project, this is the second part of our work that we did. So essentially, this is a simple Golang application that Damir did. It has a simple web interface, and it also has a support for one post request that essentially a ping response, like a ping pong application. We are deploying this application for the auto DevOps pipelines. we're using the same AutoDevops as normally. We just removed unnecessary stages like assessed and dest, because it's a really simple application and did not want to lose any time on that. The actual network deployment application is enabled by defining your network policy inside the .gitlab folder in auto-deploy values file. So you can see if I go this file, there is a network policy defined for this particular application. First of all, you have to obviously enable network policy. By default, network policies are disabled. And then you have to provide the specification. Specification is optional. This actually is a default policy that defined by us. It doesn't have to be in here. Right? I will change it later on. Just enabling here is enough. So what this policy does, it only affects ingress. It also will affect all pods within this particular application namespace, and it will allow traffic from all applications within this namespace, but it will also allow all ingress traffic from the namespaces managed by GitLab. In this particular application, this namespace is namespace where we installed Nginx ingress. So yeah, this one was already deployed. I'm just trying to find URL for that. Bear with me for a moment. I have not prepared for that. So it was deployed to this hostname. So the Zamir did that. This simple UI allows you to ping another application deployed to this cluster, and it will work based on the namespace and the service that is deployed to the cluster. Obviously, by itself, it doesn't do much. So what we did, we actually set up a second application from the branch of this repository. It has slightly different policy. As you might notice, it also adds an additional block, and this block essentially whitelist ingress traffic from the apps that I just showed you. It does it by selecting that namespace using two labels, and you can see the app name is GitLab.org defend network policy demo. It's a name that is generated automatically by CI runner for this application, and we only target production environment. So we are flexible to choose different labels. There are several combinations that you can use, but for our use cases, most interesting one. So again, I will go and try to find, yeah, I think it's this one. Yeah, it's a different app. They look exactly the same, but you should see that host names are, oops. Okay, I'm not gonna split the screen for now. Sorry. I will open it one again, once again. So yeah, what we can do is we can point this app to try to access this app, and this one should not succeed. But if we will go in opposite direction, it should succeed, that based on the policies that we deployed. I just need to grab, I think I should have, I think this one, network policy demo. Oh, network policy demo. Yep, I want this one. So we're pointing, I'm pretty sure, to this, and the service name is that, and this one is will be this, and I think this. So this one should success. Yeah, you can see I can ping there from master branch to the whitelisted branch, but if I will go in opposite direction, it will not succeed. It will be failing. We can actually check that by going and checking the logs inside the container. I think this namespace. Yep. But we want to actually do so. Yeah, we have 2 nodes of Cilium deployed on this cluster because we have 2 nodes inside the cluster. Namespace GitLab apps logs, and we need a Cilium monitor sidecar container. So those policy denied requests, I'm pretty sure is the one that we are looking for because the pods that we deployed to are 5,000. And you can see that in which direction the logs were blocked, or in which direction packets were blocked, and a reason for the blocking. In this particular case, we have level 3 network policy, which is default policy level for Kubernetes. With Cilium, we have level 4 and level 7 policies, but we are not supporting them right now. So for us, we would default the policy denied level 3. I guess that's about it. There's nothing else to show. Any questions?
I'm going to voice what I think you just demoed, and you tell me where I am wrong. And all right, so what I am seeing is that there are 2 different applications that have been deployed to a Kubernetes pod, each of which has their own network policies that have been applied. One that has been completely locked down, it can only talk within its own application. One that has been opened up so it can speak to other applications within the pod itself. And what this UI is showing is that the network policies are doing their jobs, where one is allowed to connect out to other applications and the other one cannot. It has been completely isolated. So is that?
Yeah, that's exactly correct.
Okay. Now,
can I just mention a couple of things? Oh, sorry, Thomas.
Go for it. Go for it, Zamir, and then I'm going to be quiet and let PM ask questions too.
So the cluster, the first part, as Arthur said about the Cilium, we rely on the cluster management apps. That's a feature by itself. The second part, for network policies, we rely on the auto-deploy apps. And so we are basically integrating with existing pieces of the GitLab. And the reason that the application requires a namespace and the serves is because when you deploy application with GitLab, you get an ingress entry, but we cannot use that because if you use that, you're actually relying on ingress and Nginx that's going to allow you to access the pod. When you go with the serves and namespace, then you actually try to go to the connection that we look for. We look forward to the network policy. That's it. Hopefully this adds a little bit of information. And on the Kubernetes side, if you, on the logs over there, there is a couple of numbers, and you can grab a couple of those numbers if you query for Cilium endpoints. You can map these numbers, 304, for example, to an actual pod that you're looking for.
You can also do this by IP because they're visible and you can see the direction of the traffic. I think it might be a bit easier.
And that's it from my side. Thanks for the presentation, Arthur.
So I have a quick question, obviously being new, where I've only been here a week, but if we could go back, I'm just wondering if you can show me again what the process looked like to set the network policy for each project. I know we talked about having 2 different projects. It looked like it was pulling from a third project where this YAML file is stored, or how does it know which, where are we setting the network policy?
Yeah, we're setting network policy inside the actual project that we're deploying. So as Amir mentioned, we're relying, so the way auto-deploy pipelines work with the GitLab is that you package your application inside a Docker container, then Docker container get pulled by our runner, and we're using Helm chart based on your image to deploy your application. So what we did is we actually hooked up into that pipeline, and we modified auto-deploy Helm chart to also check your repository, the repository you're actually deploying. And it will look inside the .gitlab folder in your actual project, and for a file that's named auto-deploy values.yaml. So again, it's located in the repository of our customers that specifically their app and what they want to deploy. It's co-located in the same repository. So our Helm chart can look into this file and see that first of all, network policy is defined and enabled, and then there is a specification for network policy. So again, this file is inside the repository that is being deployed by after deployed pipeline.
Okay, so it's hard coded to look in .gitlab/autodeployvalues.yaml for their network policies.
It's controlled by environment variable. You can change the name of this file, but default is .gitlab autodeploy values.yaml.
Okay, that answers my question. Thank you.
So you mentioned we're doing the filtering at level 3. You said we don't support level 4 and level 7. You said that was just for Cilium?
Cilium supports more than just level 3, but Kubernetes specification only works on based on level 3 policies. By that, I mean level 4, those levels is defined by network levels. It's the same level. So essentially level 3, it's by IP, CIDRs, ports, that all is defined by Kubernetes specification and it's supported by Cilium. But Cilium can do more than that. For example, for level 4 policies, you can target protocols specifically. And for level 7 policies, which is HTTP level, you can also define your policies based on endpoints. For example, for this particular app, we could go as far as block, for example, post request specifically, rather than the whole application. To define level 3 and level 4 and level 7 policies, we have to support what is called custom resource definition that Cilium installs in your cluster. And it's essentially augmentation over the official specification. It uses the same basic structure, but it can allow you to define additional blocks that are not supported right now by the specification. They might be supported in the future, but right now not. This is something we could potentially allow our customers to use, but right now we're strictly supporting what is supported by Kubernetes specification, and this is only level 3.
Gotcha. I think that was where I was going with that, was so this isn't a limitation of what we've implemented, it's a Kubernetes limitation, as long as we're going only to spec. Okay, it's good to know. Thank you.
The one moment that I probably did not highlight, a lot of work went into the assignment of the labels. That was not something the GitLab did before. Like the values that you see on the screen that I'm highlighting, those were not previously assigned to the namespaces, and these labels are essential for writing custom policies. So without labels, you would have to go and assign labels that you need inside your Kubernetes classes manually before you will be able to define a custom policy. But right now, a lot of labels are already predefined for you. For example, you can straight away target environments that you are only interested in. For example, you can only whitelist staging in application inside your custom policy, or you can whitelist specific application name. So writing custom policies is super easy right now. And I think we can easily encourage people to do that. It's something that's really straightforward.
Oh, this is great. I think people are going to be very excited about this.
That's good to hear.
Yeah, good job. I've been watching this issue since I started interviewing, so it's good to see the progress on this.
Y'all have been, this has been anticipated. Everybody look out. All right. All right. Any additional questions before we close this out? Well, cool. All right. Then we'll stop the recording on this, and